welcome. Today I will be outlining the origin of the Milaca soil series using tools provided by the USDA NRCS, as well as some of my own general knowledge from experience, and I hope that through viewing this you might be able to do the same thing with any series that you might be interested in. So to begin, the Milaca series occurs on what is known as the central Minnesota outwash plain, and as you can see by the map, it is located mostly in east central Minnesota, and it is actually named after a town right about in the middle of the series' extent.
The Milaca soil series is a very deep, moderately well-drained soil formed on the loamy till of drumlins and moraines of the Des Moines Lobe, which is from the late Wisconsinian glaciation. It is typically found on 1 to 6% convex slopes, which is typically occurring on summits or shoulders of upland formations on what is now, as you can see here, or has been in the past, farmland. In this particular area, drumlins are the more common formation. Drumlins, by definition, are hills formed from the movement of glaciers over a firmer sediment or some other obstruction in the land. The sediment being carried by the glacier along the bottom of the glacier has to go up, over, and around this firmer sediment. And in doing so, the glacier deposits some of its sediment that it's carrying around, over, and then behind as the glacier moves. These hills often have a steep slope on one side where the glacier initially had to go up and over the obstruction, and as the glacier then moves back down and around, it has a much gentler slope on the following side. But because of this sort of movement, the glacier deposits a lot of different materials of many different sizes all at once.
The Milaca soil series has been said to have 0 to 15% rock fragments, and in this particular area on the map, unit C73C, the Milaca series has the modifier of stony on it. This means that it has at least 15% rock fragments by volume in the profile, and stony indicates rock fragment sizes between 250 and 600 millimeters, which is almost 10 inches to about 23.5 inches in diameter. As you can see in this area, it is very evident that this is indeed glacial till rock. So you can see some of the rocks have rounded edges, indicating that they were ground and smoothed, and yet they were also broken by such high energy transport and grinding of the rocks against each other. This leads to some fairly interesting management practices and difficulties with agriculture. Lack of seed depth and seed spacing uniformity tends to be an accepted fact on fields that look like this, because there's no way to get your fields 100% rock free, and the planter is obviously going to have trouble getting uniform placement when it is bouncing over rocks such as these. And rolling bean fields for rocks is not a strange practice in this area either, but it tends to come with a lot more noise, and you move a little bit slower in fields that look like this. The Milaca soil series is classified as coarse loamy in family particle size classification. The common soil textures specifically for this series is the fine sandy loam or loamy fine sand. As you can see here, it is in fact very coarse, and there's actually an irrigator on this particular field because of the low water holding capacity of these soils. Despite them being very deep, it moves quickly out of the root zone of most crop plants. So as I just mentioned, coarse loamy describes the family particle size classification of this series. It is the most specific level that you can go to in soil taxonomy besides the series name itself, which kind of describes all of this. So in other words, the Milaca soil series taxonomic name is a coarse loamy mixed superactive frigid oxyaquic glossodolph. And because each of these things describes something about the soil, each of these things are then related to what made the soil the way it is. So we're going to briefly go through each of these and how it relates to how the soil got to be the way it is. To get back now to what coarse loamy means. Coarse loamy signifies the possible textures that could be found on this soil. It means there is greater than or equal to 15% fine sand or coarser, so sands, and less than 18% clay. Knowing what we know about how this soil was deposited by a glacier and the fact that large rock fragments can be found in it, it makes sense that coarser soil particles could also be found if such large stones are also found here. Next, we have mixed and superactive. So mixed refers to the mineralogy of the soil, and it simply means that there are many different minerals present. This should not be surprising, being that when a glacier moves, it picks up and deposits over anything that it comes across, so it mixes a lot of different things together. And superactive refers to the cation exchange capacity of a soil. CEC, it has to do with the fertility potential, the potential of the soil to hold on to nutrients and then release them back to solution for plant use. Calcite, one of the minerals very common to Midwest, late Wisconsinian till, has very high cation exchange capacity. Then there is frigid. So frigid is the word used to describe average annual temperatures between 0 and 8 degrees Celsius. This is probably not surprising as far north in the United States as central Minnesota is. And then next there is oxyaquic. Aquic indicates when the soil has saturation within the profile, and oxyaquic means that this saturation occurs for only a short part of the year. Because the saturation is there and then it later is allowed to dry, it causes oxidation of the metal minerals such as iron rather than reduction. And we know that when iron oxidizes, it turns kind of reddish color. So as we can see here, UC Davis has a site called SoilWeb in which you can not only see where it occurs, but an example of what a profile might look like. So you can see here that the B horizons and the C horizon are that reddish brown color. Next, the gloss prefix on the word glossodolph indicates the presence of a glossic horizon. So to begin, an albic horizon is what happens when you have water infiltration moving clays out of that part of a profile. So as the clays are moving down out of the albic, they are then accumulating in the horizon below. This accumulating horizon is then known as an argillic. So, to go back to glossic, a glossic horizon is when an argillic horizon that had that clay accumulation is starting to be infiltrated by albic processes. So the clay that had moved in is now starting to move out again. So there's a presence of both of these characteristics and processes kind of tonguing and waving through this profile, as you can see in The picture indicated is a very good picture of both of these processes happening. So to go back to the profile figure, you can see the B/E is the letter profile indication of a glossic horizon. Then in the Glossudolph word, Eud indicates a eutic soil moisture regime. So the easiest way this is thought of and associated with is humid regions, humid temperate regions usually. Precipitation is evenly dispersed through all parts of the year. In the northern part of the United States, this includes snow. And it means that the profile is not dry in any part for more than 45 consecutive days after June 21st. This finally brings us to the alph suffix of Glossudolph. Alph indicates that this is of the soil order Alphasol. And so this is going to indicate the overarching processes and characteristics of this soil. An alphasol must have an albic horizon. So remembering an albic horizon is occurring when we have that clay moving out of the horizon because of water infiltration. This requires a lot of precipitation, a lot of constant precipitation, which ties back to our eutic moisture regime. So a plant that requires this much precipitation is deciduous and coniferous forests, which are common in central and northern Minnesota, is what this soil originally would have developed under before it was turned into agricultural land. And to go back to, again, the profile graphic from SoilWeb, you can see the presence of that albic horizon, which is indicated by an E. We have a glossic horizon present as well, which is why we have a Glossudolph. And then below it, if you're having that clay moving out of those upper horizons, it must be accumulating in some lower horizons. So that is why we have some well-developed BTs. This takes time, so it's a more well-developed soil. And because it is formed on drumlins in this glacial till, it's very, very deep. And with how long this soil has been developing and all the rainfall that's been occurring and all the deep root growth that used to occur under forest environments, there is actually not even a true C described by the NRCS. It is a BC, which is transitioning, which means that there is some development happening even this deep in the soil, and the true C is not even reached, because it is so deep and has had so much time to develop.